Hello, good day, spacers.
Today, we will talk about the principles of operation of a controllable pitch propellers. A controllable pitch propeller is one where the pitch is controlled manually by the pilot. Alternatively, a constant speed propeller is one where the pilot sets the desired engine speed, or the RPM, and the blade pitch is controlled automatically without the pilot's intervention so that the rotational speed remains constant. The device which controls the propeller pitch and thus speed is called propeller governor or constant speed unit. Controllable pitch propellers allow pilot to adjust the angle of the propeller blades while the aircraft is in flight. The principles of their operation involves pitch control, variable thrust, feathering, reverse thrust, and automation integration. Pitch control. The pitch angle of the blades can be adjusted either manually by the pilot or automatically by the aircraft systems. This adjustment alters the angle of attack of the blades, affecting the amount of thrust generated by the propeller. Variable thrust. By changing the pitch angle, the propeller can maintain optimal efficiency across the range of flight conditions, such as takeoff, climb, cruise, and descent. This flexibility improves overall performance and fuel efficiency. Feathering. In the event of engine failure, the controllable pitch propeller can feather its blades, meaning they rotate parallel to the airflow to minimize drag and allow for safer glide or emergency landing. Reverse thrust. Some controllable pitch propellers can also be set to produce reverse thrust by changing the pitch angle to negative values. This capability assists in decelerating the aircraft during the landing or taxiing. Automation integration. Modern aircraft often features electronic control systems that automatically adjust the propeller pitch based on various factors such as airspeed, altitude, engine power settings, and pilot inputs. Overall, controllable pitch propellers offer greater versatility and efficiency compared to fixed pitch propellers, allowing for improved performance and safety in various flight conditions.
Controllable pitch propeller. Controllable pitch propeller permit a change of blade pitch or angle while the propeller is rotating. This allows the propeller to assume a blade angle that gives the best performance for particular flight conditions. The number of pitch positions may be limited, as with a 2-position controllable propeller, or the pitch may be adjusted to any angle between the minimum and maximum pitch settings or given propeller. The use of controllable pitch propellers also makes it possible to attain the desired engine RPM for a particular flight conditions. This type of propeller is not to be confused with a constant speed propeller. With the controllable pitch type, the blade angle can be changed in flight, but the pilot must change the propeller blade angle directly. The blade angle will not change again until the pilot changes it. The use of governor is the next step in the evolution of propeller development, making way for constant speed propeller with governor systems. An example of a 2-position propeller is a Hamilton standard lightweight 2-position propeller. These types of propeller are not in wide use today. When a pitch demand signal is received, a spool valve is operated which controls the supply of low-pressure oil to the auxiliary servo motor. The auxiliary servo motor moves the sliding thrust block assembly to position the valve rod which extends into the propeller hub. The valve rod admits high-pressure oil into one side or the other of the main servo motor cylinder. The cylinder movement is transferred by a crank pin and ring to the propeller blades. The propeller blades all rotate together until the feedback signal balances the demand signal and the low pressure oil to the auxiliary servo motor is cut off. To enable emergency control propeller pitch in the event of loss of power, and spool valves can be operated by hand. The oil pumps are shaft driven. The control mechanism, which is usually hydraulic passes through the tail shaft and operation is usually from the bridge. Varying the pitch will vary the thrust provided, and since a zero pitch position exists, the engine shaft may turn continuously. The blades may rotate to provide Aston thrust, and therefore the engine does not require to be reversed.